Hello, everyone, and welcome to another Jakarta Tech Talk. My name is Serena, and joining us today is Ron Veen, who will be presenting on the topic of building cloud-native microservices with MicroProfile and Jakarta EE. If you have any questions for Ron as we move through today's presentation, feel free to ask it in the chat or use the Ask a Questions tab. Without any further delay, Ron, over to you.
Thank you. Yes, welcome everyone, and great that you actually want to join me on this introduction to Jakarta EE and MicroProfile. I'm just going to start with a short presentation to give you an idea of what we're going to be talking about, and then we'll do some hands-on coding. So that would be the agenda. A short thing about me, I'm doing something like 20 plus Java development on and off. I'm a developer and a special agent at a company called Team Rockstars IT. I do like to speak at conferences, and currently I'm writing a book on how to migrate Jakarta EE to a newer version. Right, so what is Jakarta EE? I guess we should first look at the two technologies. Well, it focuses on developing large-scale enterprise applications with the Java language, of course. It's a set of APIs, really, together with a reference implementation and a technical compatibility kit to prove that they actually meet the demands of the APIs. It was originally started as J2EE and later JEE by Sun Microsystems. It was then renamed again to Java EE by Oracle when they bought Sun. But in 2017, the Eclipse Foundation became the steward and they rebranded it to Jakarta EE. There have been 3 releases since. Java EE was the transition release from Oracle to Eclipse. Jakarta EE9 had everything moved from the JavaX namespace in packages to Jakarta. And finally, just recently released Jakarta EE10 with new functionality being added to the project, and already talks are being held now for what to include into Jakarta EE11. Looking at the platform, it consists basically of 3 profiles. There's a new core profile, which is new in Jakarta EE10, which is really targeted at microservice style applications, edge computing, things like that, where you just need a subset of the functionality, which is really small and concise. There's the web profile, which includes more functionality. And finally, there's the complete Jakarta EE10 platform, which includes all of these specifications. There's a number of vendors who are actually working on Jakarta EE or implementing it. Most notably, of course, IBM, Oracle, Pajara, Tommy Tribe, Red Hat, which have their different implementations. Then moving on to MicroProfile. So MicroProfile basically is another set of applications that bring to Jakarta EE, or formerly Java EE, what wasn't there yet, which is the cloud nativeness. Java EE had its releases, but they were very infrequent and with long intervals, which was basically a no-go in the time when we had all these developments going on with web-related technologies, and things moved so fast then. And then you had to wait like 2, 3, 4 years before you could get new things into a Java EE release. So what basically happened is that all the vendors from the different application servers, they started to implementing their own set of APIs. But if you think about it, that goes against everything what the whole JEE ID stands for. That is really to have a standard set of APIs, and now everyone was building their own set. So a group of vendors and some individuals started MicroProfile in 2016, and they said, well, we're going to make some specifications, and we're going to use some default Jakarta EE specifications, and on top of that, we're going to build our own set of specifications. So no longer every vendor having their own specifications, but we're going to make another standard on top of this one. And so they came up with specifications for resilience, configuration, metrics, distributed tracing, etc. We will go through a number of them hands-on today. It was very interesting to see that the first thing they addressed with MicroProfile was having really short release cycles. In the beginning, they were extremely short, where they just said, okay, we're hammering out this API, we're gonna put it there in the market, we're gonna see if it gets adoption. If it gets adopted, great, we'll continue it. If it doesn't, we'll see if we need to tweak it. So that went really, really, really quick. To indicate, started then in 2016, and now we're already at release 6.0. So what are the specifications and the APIs in MicroProfile? Well, as you can see here, there's a default set that everyone who wants to be MicroProfile compatible has to implement, and there's a set of standalone APIs like the long-running Actions API or the GraphQL API. No necessarily needed to be implemented, but they're still there, and there's still this demand of having some standards there as well. Again, there's a lot of people, but also a lot of the same people and companies working both on Jakarta EE and MicroProfile. So again, we see IBM, Red Hat, Tommy Tribe, we see Microsoft having a great part there, Pajara, Oracle, and so on. That was the part where we actually talked about all the slides, and now we're gonna switch to the code editor. And we're just gonna first have a look at Jakarta EE and microservices specifically within Jakarta EE. I have this tiny program started up here, and the most interesting part is, even though we are getting in all these specifications, we basically only need 2 dependencies. I need the Jakarta EE API dependency, and I need the org Eclipse MicroProfile dependency. Both state that they are provided because the underlying application server will actually implement it. So I just need the APIs here to get my code compiled. So that is our application, starting at the basics of the application and also in how JAX-RS works. JAX-RS is the RESTful API, which is part of both Jakarta EE and also leveraged in MicroProfile. You can see that we're basically telling here, okay, you are an application, and this is a class defined within the Jakarta framework, and we tell it with the application path, this is where your endpoint is and where clients can reach you. So this is the application part. Next up would be that you would have a project resource with a lot of annotations on there. So it tells here with the path annotation, okay, after the /API, if you use the /projects, this is where you can reach me. Then it tells that every input it takes, like from the body content of calls, it should be application JSON, and everything it produces itself will also be JSON format. Those are the JAX RX implementations. Then if we move on to, for instance, this method, this is something where it tells us, okay, I want to retrieve via a HTTP GET response some data from this path. And this path basically gets appended to the path we saw above. And having it defined like this, it is just a parameter. So what this really says here, if you would send something to API/projects/1, it would try to retrieve the resource, named projects with the identifier 1, which we're going to see in a second. One more thing I want to show you first is there's no database behind this application. So this application here allows us to create new projects, retrieve projects by ID or retrieve them all. There's just no database. Every time when I'm making a change to the project here, the server gets quickly compiling the code and restarts, which then leaves my in-memory database emptied. So you'll see me performing an action where I'll add some data to the database multiple times. Right, so starting with the rest of this microservice, because we first said, okay, there's a few endpoints in there, but we need to add one. We don't have a get all endpoint yet where we can retrieve all projects. Now let's see how simple it is to implement something like that. We would have a public method where we would call it get all. There's no parameters, as we want to retrieve everything. And basically we can just say, well, we're going to return a response, and a response is a response object where we can either say, okay, and it will return an HTTP 200. But in our situation, we actually want to retrieve some data. So we have a service. We'll talk how we get to this service within a second. A service find all method. And then we just need to say to the builder, okay, that was it. And that is basically how you can make a get endpoint. What we still need to do is annotate this endpoint with the get annotation so that this endpoint actually gets exposed. Now, if I would save this, then you can actually see that I have the terminal here. And it says, okay, great, this application has now been updated in 0.2 seconds and it is available. So that should give us at least the possibility to run the option here. And you see we get a response code 200 now. There's just no data in there yet. So that's why the application doesn't return anything yet. If I would enter some data, and I would run our endpoint again, then you can actually see that we're getting the data returned here in a list. And that is how simple Jakarta EE makes RESTful web services. Going back to one point that we talked about before, I said, okay, we're calling this service method here. So how did we get to the service method? It is defined up here, and it has an add inject annotation. Add inject comes from another API that MicroProfile is kind of loaning from the Jakarta project, which is CDI, or context and dependency injection. Basically, I have a project service here, which I gave a scope. In this case, it was an application scope. There's different scopes available. There's request scope, there's session scope, there's conversation scope. And depending on the profile you're choosing, there can be different scopes. Application scope basically says, kind of a singleton. I have one object which will be used for every part of the application. Because it is application scoped, it gets registered by CDI. So as soon as I say in my resource class that I want to inject project service, CDI will look if something there has been registered with that name, and if it is, then it will get automatically injected into the variable we're talking about here, service. So that is part of the dependency injection part of CDI. Then there's also the context part, and this annotation here is all about that. What it tells here is basically that it says, okay, this resource, this class has request scope, meaning for every new request coming in, I will create a new instance and hand it. So that's completely the opposite of the one we saw with application scope. Having gone through all of this, then I think we have covered the main parts from Jakarta EE used in this simple application. Perhaps there's one more feature that we should just highlight a bit. I am returning a list of Java project objects here. Still, my output gets to be in JSON. All that comes because I'm saying here, up here, it produces media type application JSON. So the JOX Eric's runtime actually knows, oh wait, I got this object, but I need to translate it to JSON. So it does all these things automatically. You don't have to work with Jackson or JSON. It's all been done for us. So that's pretty neat. Okay, moving on. These are the things we really want to talk about in relationship to Jakarta EE itself. You've got this great microservices, it's doing really great, but then you find out when you deploy it on the big bad internet that things actually might break, and things probably will break. You have this monolithic application, and suddenly you have all these smaller microservices, moving parts, much more network interaction between them. Something definitely at some point will go wrong. So we need to add a bit more cloud nativeness to it. So let's see how we can do something like that. The first thing out of the box without me doing anything is that you get an open API specification by default. If I would go to the server here and refresh this part here, you can actually see that out of the box, I'm getting a lot of open API specifications. So for each of my endpoints, it notes down, okay, was it a post? Was it a get? Was it a put? Was it a delete? What are the parameters? What needs to be in there? So that is actually quite good. It has here a complete set of all the values in there. It is out of the box like this. It is very easy to change if you decide that you really want to add some extra information to it. That is very easily done. For instance, if you say, I want to rename this parameter and it says retriever project, give it a good description, you just add it here with these standard annotations. And if we would refresh it here, it would here show that information. So it's very easy to add your own flavor to your APIs and make it very easy for your clients to use your API. Next thing on, because one of the next steps in making an application like cloud native would be configuration. According to the 12-factor app, configuration sources should always be outside of the application so that it's easily to change. Think containers, where you probably would use environment variables to configure data source URLs, user IDs, passwords, and stuff like that. They get injected in the last moment. For this, there is the config API in MicroProfile, where you basically can define a project, a configuration value, and it will look in certain hierarchical places for the right configuration value. The most default value where it will look will be inside the MicroProfile minus config.properties in the meta.inf folder. Next, it will look at property files. It will look at overrides on the JVM with the -d parameter. And finally, it will look at environment variables. And environment variables will always override the ones underneath and the ones underneath. So there's like this hierarchy. And that makes it very flexible to work with these kinds of things. Now, how do we access these configuration values if we really want to access them and have them injected into our program? Well, that's exactly again how it works. We inject them in our program. If you take a look at the output here, you can see that a project contains an active, a name, and a UID. But if we would actually look at a project, it also contains a company ID. In this case, we're not using that company ID at all because it doesn't get a value. And if it doesn't get a value, it's a null property and it won't show up in the JSON. So how can we change that? Well, I have this optional value company ID here. And when I create a post, I actually check is company ID. If it's present, then set it to that value. So currently it is nil and it won't be set. What is possible to do here is that you basically say, okay, add inject, and then you say this is a configuration property. And it has a name. In this case, it was company. That is the name that it also has in this configuration property. Watch the value 24. And then we'll just make it automatically injected here. So now if I would run this application again, and if I would post a new value, you can actually see here that suddenly company ID gets filled with this value. So it's really injected, and this is the way you can inject your URLs, your passwords, whatever you need can be injected this way into your code. Now, what is interesting about configuration, for instance, is that in version 2.0, suddenly you have the possibility to define profiles. And profiles basically saying, okay, I got a different set of parameters for development, for test, for staging, and for production. And I can have all these values in my environment, and based on a setting mp.config.profile, where I can specify which is the current active profile, it will take the right configuration properties. That really makes it very handy to use and very easy to switch environments. So there was a great addition in version 2.0. Another addition was that we could add property expressions. Before they were really static, and now we can have in our properties itself have expressions, which is really nice. And finally, another option that is quite usable is something called a config value. Because I just told you there's all these sources where a property value can come from. And sometimes you're just not getting the property you would really want to, and still you wonder, where does it come from? Well, if we would do something like this, we say, okay, this is still a config property. I want you to inject it, and I want to know the config values. Where does it come from? Now, if I would take one of these endpoints and I would just tell it, okay, just give me a system out print line. For the config value, where from, and then I want to see, okay, what is this actual source name? I'm saving this, and I would again call the endpoint. And I would look at the output terminal. It tells me, oh, this comes from a property source config, and it comes from the classes meta and microprofile config.properties. So that's a very nice, neat, easy trick to debug your application if you're in doubt where the value comes from. Great. Well, moving on to the next one. We have our API. We got it exposed via OpenAPI. We got the application configured. So the next cloud native point that we would address would be health. And that would be the health of your application. Your service can actually tell outside sources how he's doing. The whole idea is that with the health service, you check the validity, the availability, and the status of your microservices. For this, there's actually 3 annotations and 3 endpoints that can be exposed. There's the ready endpoint, which basically tells you, is my business logic ready to process events? There is the live endpoint that basically says, is my service still responding at all? So it's still acting as I would expect it to act. So more on a technical level as opposed to the readiness. And there's finally a startup endpoint telling to the outside world, I'm actually still in the process of starting up. As you can imagine, all these endpoints, they're really machine-to-machine endpoints. They're not really meant for us users to check them all the time. They're really meant for container managers like Kubernetes to check the health endpoints and see, do I need to restart this pod because its liveliness endpoint really doesn't give us any good information anymore. So that's really what it's meant for. Still, we need to implement them ourselves. It is again a CDI bean. So let's see how we can implement such a thing. If we define a normal class, then we need to implement the health check interface in order to make it health endpoint, and it has one method, and that is the health. That's the method call that should return a health check response. Right. So what to do? Well, the health check response, we can give it a name. In our case, we'll call this the project thing, and then we can decide, okay, is it going to be up or is it going to be down, depending on if the server is running or isn't running. You can also return it a status. You could say it is up, and then you say build. And this is basically your endpoint saying, I'm doing very well. Now, in normal implementations, you would typically add some additional data, maybe check your database connections, check if you can reach external systems that you need to reach, check if you can actually write to the Kafka queue stream, stuff like that. So that's normally a bit more than to just returning up and saying you're ready. If you would want to supply extra data, maybe they're just saying, I'm having a problem with my database. So I'm trying to reach the Redis cache and it gives a problem or something. You could actually make it available to the outside world as additional information like this. So you can add an unlimited set of information to this. Now, even though we implemented the health check, it is still not a health check. We need to do a few things. First of all, we would make this application scope, because for our complete application, we're defining just one health check here. Next, we need to say in which situation should this health check be called. Well, we just said we had the readiness, we had the liveliness, and we had the startup. Well, with all these added, our health check application part here is completed. It got newly deployed. So if I would now go to the endpoint, which is always the health endpoint in a project, which is at the server name and then health, and I would run it, you can actually hopefully see here that it returned the information that we gave it. So it still says my status is up, this is my project, and without a typo, it would have said, I am not available. So this gives you really, really nice, quick information and on how your system is doing. And actually it gives, like again, container management systems the needed application. So what did we learn from this? So health service beans, again, they're CDI beans, in this case, application scoped. They need to return a health check response. So we have our API, we have our configuration, we have the health. Next thing we actually might want to know is, how is my server actually doing? So how are its how is the how often is a method called? What is the average response time for a method? What are the longest delays? You know, all these kinds of metrics. And for that, there's the metrics project within MicroProfile, and it provides us with a number of metrics that we can apply. There's the timed annotation that has all kinds of information about, okay, how long did it take, and how often, and which buckets of response percentages did it land in. There's the counted, just basically saying, okay, how often have I been invoked? And there's different gauges and meters and histograms that we can use. We are in our situation, we're going to just look at a few of these. And going back to our resource that we had here, now we might want to know, how often does this get all method? How often does it get called? Now, maybe you would like to know it on this level, where you say, this is really, I just want to know how often it gets invoked. And it is really as simple as saying, I'm doing a counted here. There's additional parameters that you can use to specify what name it should have, and in which bucket it should be. So there's all lines of all options for configuration out of the box. The add counted is enough. Now let's see how this works out. If we would go to the HTTP request and fire multiple times on this get all endpoint, it's returning us a number of 2. And now if I would actually say, okay, give me the metrics for this specific application, it actually comes down with quite a large payload. So I'll just use this in the browser. And that didn't work at all, did it? Here, actually, I'll just zoom in a bit. You see that we have a counter here. It's the application and then the name of the project, the method being invoked on what service, and the type of counter. And it tells you, okay, well, this count, it has a total of 6 times that it has been invoked. All these metrics, they're in a Prometheus format, so they're easily exported into that format. Basically, as endpoints, you can just get the data out there, get it loaded in, for instance, Prometheus, and have it displayed in graphical views. So this was for this very specific one. There's also already a whole lot of stuff being exported by default by your running application. So it tells you, for instance, okay, how many threads are running in the system, how many classes did the class loader unload, how long has the JVM been up. So there's a lot of things from the application, from Java itself, that is actually being exported, and where you can either use them or you can't. But it's very nice if you want to see, okay, what's CPU usage right now on this service, how much disk space is left, although you probably have to add that one in yourself, how much memory is being used. So very, very useful stuff which is in there. And then we're going to add one more, because we just added on the health service, on the project service, the counted, but maybe for a normal call to get all. I would like to know also, the turnaround time. So how much time does it actually take for the complete trip to complete? So I'm getting the request in, I'm calling the backend service retrieves data from the database, reports it back. This data is going to get converted into JSON, and that is being returned to the client. So how long would that take? Oh, there's another annotation, timed. Again, with this annotation, you can use a lot of parameters to set your stuff for specifically for your metrics. But this add timed as it is suffices to have it working. So I'm saving this, going to the endpoint again, calling it a number of times, and then see what ended up in the metrics now. Nothing here. I should go to that endpoint. Metrics application. And though it almost looks as if we had a complete set again, it didn't. It still got to our counter that got increased again, but you can also see that it also has the information for the get all method and how long it took. And there's the average 1 minute rate, minimum rate per second. So there's like all these percentiles as well. So there's a lot of information being gathered there about how the performance of your system is. And you can imagine that if you look at these figures and you have some graphical system to represent them, you can get very, very good insight into the ongoing performance of your system and the average throughput of your system. So metrics, very important to make your application more visible and more reliable. See what's going on the inside. Good. And then moving on, we'll get to the final API that we're going to be discussing today, and that is fault tolerance. Okay, one more time. We got the API, we got the configurations, we got the health, we got the metrics. But now something might sometimes go wrong in our application. Now, the health service is already helping us part there, right? Because basically it says, okay, Kubernetes, if you think I'm not doing well anymore, I'll tell you over my liveliness service. And if I'm doing really bad, please restart me. And that is what Kubernetes will do. But that's kind of a very coarse-grained solution, isn't it? I mean, you don't really want to restart your complete application or your pod or your container or whatever, just because there might be some hiccup somewhere. So maybe you want to have more fine-grained control over what is going on in the system, and try to make the system self-correct itself, self-heal itself. Well, for this, there is the fault tolerance module within MicroProfile. And we will now look at a few options that it actually offers to us. If I would go to the project service, and then there is this very basic find all method that we just had before. I'm just taking out the counted. Well, the most basic and the most easy option would be that you give it a retry. You say at retry, and you state the number of times it should retry the operation should it fail. You can also specify a max duration. In this case, I put in 1,000, and 1,000 in this would be milliseconds. But it is possible to actually specify the duration unit yourself. So if you would like 1 minute, then you could just specify 3600 milliseconds or just one, and then a time unit of a minute. As you can see, there's also some other parameters that can be specified, like jitter, which is some kind of a random interval where it will wait until retrying again. But basically, we'll get quite a long way by just specifying what we have here. Now, should these 1000 milliseconds expire before we had the maximum of 3 retries, then the system will just say, okay, I'm done here. We're not going to try any more retries. So this is really the cutoff time. And talking about cutoff time, there is something similar, which would be the timeout, where you again can specify in the time unit you want how long does this call maximum is allowed to take. So how quickly should it end? So in this case, we're saying it can actually take 1500 milliseconds. So it would be 1.5 seconds. And if it doesn't complete within that time, it will give a timeout exception. We'll later see this one in action when we do the last piece of coding. First, we'll move on to a different option we can use, which is the circuit breaker. And the circuit breaker is really quite an interesting one. You can really see it like a power circuit in your house, like a power line. Basically, the circuit is always closed. Nothing is wrong, the circuit is closed. But then if something goes wrong, it might end up in a different state. In this case, we're telling it if in a request volume threshold of 10 calls, so 10 calls, if there's a failure rate of 0.5, meaning from the 10 calls, 5 failed, I actually want you to open the circuit halfway. And what it will do is actually wait for 1000 milliseconds until it accepts any further traffic. Then once these 1000 milliseconds have passed, slowly traffic will be sent again to this endpoint or to this method. And once there's a success threshold of 3, meaning that 3 successive calls are successful and completed successfully, then the circuit will close completely again and all traffic can flow through again. So this is a really powerful option to use because you really can give the system some time with the delay. Okay, maybe you're kind of busy right now, or you're struggling with something, or you have something like memory that is being reorganized at the moment. So just give yourself some time and maybe you'll recover yourself. Based on a pattern to limit the output of the problems that are occurring, there's another pattern which is called the bulkhead pattern, which is basically a very simple pattern, and there's this analogy to shipping, hence the name bulkhead. If there's a big container ship and the hull gets breached because it touches an iceberg or whatever, then if nothing has been done, then the whole ship will flood with water and it will eventually sink. So what they've done with these big container ships is that they made different compartments. And if one compartment gets breached, it will be closed off from the rest and water can't get in anymore. And this analogy, so meaning the ship won't sink. And this analogy works perfectly for what is happening here. If we would have all these methods that you see here, these 5 methods, and only the find all would really perform very badly, that at some point, all the threads will be busy with processing find all methods, that the rest of the system is basically starving and doesn't get any response anymore. So there's one little part in your system that is performing badly, maybe because you're going to an external system, it's suddenly kicking down your complete system. Now, with bulkhead pattern, basically, you can prevent those things. There's two flavors, won't go too much into them. There's the semaphore pattern and there's the thread pool. Basically here, the semaphore pattern says, okay, there's only 5 maximum concurrent invocations of find all. So that 5 calls can come in from a client and I will process them. I won't do a 6th one. Why? Well, if we have a thread pool for 20 and we would do it unlimited, then basically calls would come in, they would take long to process, threads get blocked, and none of the other 15 threads, which would be in our 20 thread pool, would be able to answer to the other methods anymore. So this is really a good way to protect your system. And there's finally a final annotation, because sometimes, even though you try your best and all the other things, they really try to fix the system, give it a retry, gave it a longer delays, try to make the system still responsive with the bulkhead and the circuit breaker. Sometimes things just fail. And there's one final method that we can actually use. And that would be the retry. Sorry, not the retry, of course. That would be the fallback. And what the fallback basically says is, okay, if there's nothing I can do anymore, I really can't reach that source where you want me to get the data from, I can either be really nasty and give a 500 server error, or I can just be a bit more graceful. Now, let's see what's happening if we don't do it gracefully. So if we put an annotation on here and we say, there's a timeout of 1000 milliseconds, and then we'll just make the system a bit slow by saying we'll do a thread sleep of 2500 milliseconds. Now, I guess you can imagine what's going to happen. The system will say, okay, well, sorry, you didn't respond in time and something is wrong. So if we would do it like this, and I would call the method, I'll just clean this down here. Sorry, it doesn't have the endpoint anymore. That's funny, it should have had that. Seems to be something wrong. Okay. We can't use this one yet because it isn't there yet. Method, so that's why it won't fail. Now it worked. So I'm trying to call it again within these delays. The system will wait a bit, and we will end with the infamous 500 internal server error, which isn't very elegant. Now, if you decide, no, I want to do it differently, I'll maybe instead of returning a 500, I would just like to, well, I don't know, I'll return an empty list then or something, or maybe you got your data. Maybe you got your data somewhere in a caching system, and you could say, oh, well, I'll see if that works for me. So I'll just return maybe an older view, but still better than giving a 500. Now, we said here we have a backup method, so we just need to define one here. And the only thing that is important is that it should have return the same data type as the method it is a backup for. So in this case, we would say list project backup, have no parameters. Now, we don't have anything to return right now. So in this case, I guess I could just say, I'll return an empty list. Might not be great, but it might be an indication to the user at least that, oh, okay, he didn't find any projects that can't be right. So something must be going on. So having saved this and trying to invoke this method again. I'll just clear it here, invoke the method again. Then you actually see that we're getting a 200 saying okay, and we got a response of 2 bytes, meaning just the empty JSON array. So we can still return some kind of value that could be of use to our users. Great. So this was the end of the presentation. So I guess now is a good time if there are any questions.
There is. Thank you so much, Ron, for that amazing presentation and demo. We do have 2 questions. We have one from Helmut. So it's, if you have a real database as backend, would you use EJB annotations instead of CDI?
Oh, that's a very interesting question. I guess it really depends upon, because AGBs in the old type, in the old style, there were like 2 things. There were like services, and there would also be persistence. Persistence is now separately. In this case, I think I would, even if I had a real database, I would still use our normal things that we're using right now, the way I used it now, because there we also can have transactions in there. So there's no reason to use AGBs. I can see why you want to do that. But you can use the same. I understand, because there's also a singleton scope within AGB beans that kind of compared to the application scope. But you can use basically both. It really depends also if you would go to the core profile that I was showing before. I'll just pick it up here. We have this core profile on the right. Basically, beans are no longer part of that. They're enterprise beans, they're in the web profile, but they're not in a core profile. And with you working in a core profile with your microservices, you would have no other alternative than to use the annotations I already used.
Okay, great. And another question from the same person is it possible to react in a health service system metrics, P.E, force a reboot by marking a system as down if the memory footprint surpasses a limit?
Yes, what you could force a reboot, of course, because you have all these metrics available. You can even inject them, individual metrics, and or retrieve them from the metrics registry. And what you could do in your health service, of course, is go to this metric registry, look at, okay, what's my current memory footprint? Is it below a threshold? Then I'll just return not the up like I did before, but return the down. And the down would then be an indicator to the container management platform like Kubernetes to say, oh, wait a minute, you gave me a down, then I'll automatically reboot the container. So it would still be like the container management platform that would do the reboot, but you can actually give it an indication saying, let's reboot. Yes, definitely. Good question.
Great. And then the last question is, what happens if the circuit breaker can't fix the problem? Are there any automatic fixtures?
Yeah, that is actually also a very good question, Helmut. Let me show you one example that I didn't even get to, but I would really love to show. I'm just taking out everything I had here. Go back to the original one. And then, because I just showed them in all individually, but it is actually very, very possible to have all these things run together as one big group of set that is running in conjunction. So let's look at this code here. Basically, I got a circuit breaker. a retry, the bulkhead, and the timeout, and a fallback method. So that they're all in there, right? So first what happens is we get to this message, find all, and the circuit breaker will first check, is the circuit open? If the circuit is open, no traffic will flow to it, and it will find a different method. Now, if it is not open, but closed, that means the traffic will go through, and the bulkhead, the timeout will actually start. A timer will start running, see that we don't surpass the 500 milliseconds. The next thing that will happen is that the bulkhead will look, is there still a spot for me? Am I allowed to execute this method, or are there already too many executing? Now, if it isn't, then it will just execute as normal. If it would be, if the bulkhead would say, no, we can't do it right now because all the threads are used, it will actually throw a bulkhead exception, which will then be caught, and then the retry will take over again. And this continues to work in conjunction, so they keep working like this. The circuit breaker might go open, it will retry again, and in the end, if we can't get a decent result, it will go to the fallback method. So long answer to the question, yes, it can fix it. The circuit breaker will throw an exception, but if you use them in conjunction, then you actually might have automatic fixtures in place.
Okay, great. It doesn't look like there's any other questions. So we're also looking to book some more Jakarta Tech Talks throughout 2023. So if anyone is interested, I did link the form in the chat. And finally, if you have any feedback on the Tech Talk programs, we would love to hear from you. So when we close out this chat, you're going to get a little thumbs up or red thumbs down, and just, give us some feedback if you enjoyed this talk, and if not, you can also give us some feedback on ways that we can improve. So I just want to say thank you so much, Ron, again, and everyone for attending, and I hope you all have a wonderful day.
Oh, thank you very much.
Thank you so much. Take care.
Okay, bye-bye.
Bye.